All right, friends. Week 4, lecture 2, couple housekeeping things. You have a discussion question this week, and you've got a core assignment. Or let's see what your core assignments are. You actually have 2 core assignments. You have books, ERD, and ninjas, dojos, and ninjas. Jeffrey, for you, for books, ERD, if you're trying to do that, or even these, if you just send me screenshots and do that, that's fine. Versus the file, since you have the Sonoma issue, just to make sure you get
Oh,
those in on time, and then I'll look and try to figure it out. But because it's due Sunday, if I can't figure it out by tomorrow, just feel free to send in a screenshot, and that'll work just fine.
okay, I will.
Cool. Awesome. Well, like I said, today, instead of an algorithm, what I kind of wanted to just touch on is classes. Um, does anybody know kind of what coding paradigm, it's a big word, what coding paradigm classes are sort of a part of? It's 3 letters. Did Nathan talk about that?
I have a question, Will.
Yeah, go ahead, Jeffrey.
I'm sorry, what do you mean by you say coding paradigm?
Yeah, paradigms, great question, is really just a thought process of how we're going to set up our code.
Oh, yes. Um, is it the pillars or something like that?
Yeah, so there's 4 pillars of this specific type. Does anybody remember what the
Yes.
specific type is called?
So
Are is
we have
oh,
inheritance, we have,
Yeah.
or do you want us to name them according
polymorphism?
Yeah. Great.
polymorphism,
Morphism,
encapsulation,
encapsulation.
um,
One more.
there is one that goes with which one is
Yeah.
that?
That's called abstraction.
Yes.
Great. So these are the 4 pillars of, anybody know?
Object-oriented programming.
Yeah, exactly, Kevin. Now, this is something to know, programming, because sometimes I've heard that I've never had this happen to me, but whenever you're talking about, especially if you're going for a junior dev role, they might ask you, what are the 4 pillars? Or can you describe to me OOP and what are the 4 pillars? And so you'll need to be able to know, this is often referred to as OOP, it's object-oriented programming. You'll need to know what the 4 pillars are. So
And you'll
for,
that so but like just not knowing those four, being able to list the four isn't enough. You actually have to define what
yep,
each of those are.
yep, exactly.
Mhm.
So these are the 4 pillars of OOP. And OOP is a way that we can set up our code in what we call objects. So that way we can refer and not continue to repeat ourselves, which comes into something else called dry code. Now, dry code stands for do not or don't
Repeat yourself.
repeat, yeah, yourself, right? And so the whole idea is if I were to say something like, Marley equals, and maybe it's a name, Marley, maybe it's a type, maybe I'm talking about my dog, Marley.
Doesn't Marley have to be in quotation marks?
Yeah, I was just heading back there. Maybe age is 8. So let's say I wanted to create a project that is for my dogs, right? Well, I have 2 dogs, Marley and Charlie. So then I would have to basically do this. Charlie. Okay. He's 5. But you see that I'm sort of repeating myself in the same ways. Not necessarily with the types or the names or the ages, but more so with or not necessarily on this side, but on this side, I'm kind of setting up the same object or dictionary over and over and over again. And let's say that I had 100 animals, this can get really, really tedious, right? And so what we can do is instead of doing that, we can create something called a class. And we're going to call this pet, right? And what pet does is it has a couple different attributes and features. Ooh, I'm going to comment this out for a second. Now, what this does is instead of having to redefine name, type, age, name, type, age, we can say, hey, we're going to create this class of pet, this blueprint for what a pet really is. And the information we need to know is its name, is its type, and its age, right? Maybe I'll say okay. Now, what this does is it allows me to not have to rewrite this, and I can create and say, okay, here's a blueprint. If I want to create a couple pets or 100 pets, we're going to use this blueprint to create it. Now, the way we do that is we create what we call a class. And all we do is we say class and then the class name. Now, this is in Pascal's case. Pascal case. Anybody know what that means? Anybody know what Pascal case means? Pascal case is your class name always starts with a capital letter. And then if it's multiple words, each other word also starts with a capital letter, and it's combined just like this. So if I had multiple words, Pascal case dog, it's going to, if my class was 3 words, here's these 3 words combined, and each of them start with an uppercase letter.
I thought that was camel case.
Camel case would be if the first one starts with a lowercase, and then the
Okay.
remaining start with a capital. But Pascal case is every word or every new word starts with a capital letter.
Okay.
Cool. Now, here we have something called our constructor. This constructor is a method. Does anybody know the difference between a function and a method? There's one little difference. A method and a function are the exact same thing. They operate in the same way. We define them in the same way. The only difference is if this belongs to a class, we refer to it as a method. So if the function belongs to a class, we call it a method. If it doesn't belong to a class, we call it a function. That's it. Operates the same way. Python reads it the same way. It's just one's associated to a class and one's not. That's it. So if I say function or method, they're interchangeable. Just knowing that, hey, if it's and I'll do my best, but if it's associated to a class, it is a method. If it's not, if we just had some random, function outside, that's just referred to as a function. And so what this constructor does is anytime we instantiate or create a new instance of my class, pet, it runs this file, this init. Now, the way we set up our constructor is we say def, again, just like we would any normal function. But then we do this thing called an initializer, right? And the way that works is we do something called a dunder. So it's really easy to accidentally do just singular. What a dunder means double underscore. It is 2 underscores. So our init needs to be 2 underscores. So we have 2 underscores, init, 2 underscores.
So what is a dunder?
It means double underscore.
Double underscore. Okay.
Yeah. Mm-hmm. Yeah, I don't just have one, I've got another one. So double underscore. And in this constructor, we take in what is necessary for us to create a pet. So here, what's really important is we have this keyword of self. Can anybody tell me what self is? Anybody know what self is?
It's a placeholder?
It's not a placeholder. Good idea, though. I could see where you get that. What self allows us to do is when we are creating a specific pet. So when I'm going to create Marley, it's allowing me to attach values of like name to that specific instance. It's a way for us to tell the computer, hey, when I'm creating Marley, I want Marley's name. So self.name, this specific instance's name to be Marley. This specific instance's type to be dog. This specific instance's age to be 8. So it allows us to identify, hey, I'm only talking about this instance right here. I'm not talking about all of them. I'm talking about this specific instance. What we also put in our constructor are the values needed for us to create this, in this case, pet. And I have one more that's self.energy, and that equals energy.
So like each of those, so self basically, could you go over that again? I'm not about
Yeah.
self.
Of course. So remember, maybe if I just do something like this, say Marley equals pet Marley dog 8. This is a line
Right.
that I'm confused why it's saying that's not defined. Because class pet is right there. Where I'm saying Marley equals,
Probably because you're missing energy in the
no, 'cause
constructor.
energy, great question. Energy, I give it a default value here, so I don't have to pass in anything.
Okay.
Let me see. I'm gonna run this and see if it, just real quick, sorry. Make sure I'm not. That is not defined, but it is.
You know, well, that's what happened to me when I was writing my name. It said my name wasn't defined.
As you're seeing, it says class pet definite.
That's weird. I would say pet isn't defined, but obviously it is. That's
Oh, I am Python. You have to have correct spacing. I am still within my class. So see, now it works. Okay. Sorry about that. I was like, what is going
okay.
on? But now if I say this, we get this object here. Cool. So what this does, Kevin, is when I'm saying Marley, right, I'm creating a new instance of my class.
Right. Yeah, I know that's an instance. Yep.
Cool. And
That
so
makes sense.
what's happening is self allows me to say is, hey, this specific instance that I'm creating, its name, so this specific instance's name is
Mhm.
Marley.
Okay.
This specific instance's type is dog. This
Okay.
specific instance's age is 8. And so if I'm having multiple types.
Oh, so right. So I see. So no, that's why. So self is kind of the reason why you don't have to put, you only have to put something for name, type, and age. You don't have to put self in each of those instances.
Yeah, I don't have to because self is assigning. It's, remember, it's constructing. It's saying, hey,
Right.
when this class is being
Right.
constructed, I'm assigning this specific new instance's
Right.
name to
Okay.
whatever was passed in as name. Now, Shirley, you asked, do I need to put energy? Up here is what we call a default parameter. Remember that if I don't pass in any value here, which I didn't, it's going to default to 100. If I wanted to pass in a value, because Marley's a little bit older, so she's got a little bit less energy, it'll allow that and it'll change it's saying, oh, I did get a value. Now energy is going to be 50. If I don't put that, like I didn't for Charlie, it's
Okay.
going to say, oh, I didn't get a value here. So I'm just going to assume it's 100.
Okay.
So I see. So the self allows us to attach attach values of Marley, dog, and 8 that correspond to name, type, and age to the instance of Marley
Exactly.
and
Exactly.
Charlie and so on. Okay.
Yeah, it's saying, hey, just this specific instance that I'm dealing with. Not all of them. I don't
Okay.
want to globally change them. I don't want to change all animals. I just want this specific instances.
Right.
Name is Marley. Yeah. Cool. So we take all of our values, and this is what creates our object. Now, you can see that whenever I printed Marley, what it does is it actually gives me just where the object is located. Now, that's a weird Python thing. So there's a couple things we could do. If I wanted Marley's name, because I'm now dealing with a class. Now, if you remember, if I wanted to get this name right here, what would I have to type if I wanted to print that out? Oh, it did it for me. But remember, when I'm dealing with a dictionary, I say Marley, bracket, even though it's confusing because it's a dictionary, it's always bracket, and then the key name, right? Well, what I could do with a class is do something called dot notation. And so here I can actually just put name. And this is going to go in to my instance of pet. That is Marley. And it's going to grab that specific instances because, self allowed me to just name that specific instance. And it's going to grab that specific instance's name. So when I run this, I get Marley. I could say H. And I get 8. And we can even see just that, just to show that the default parameter was overridden because I passed in a value here. It overwrites this and the energy is 50. Okay, I'm going to pause there. Are there any questions?
Right. So in other words, if you just created a value for name, type, and age, and you didn't do anything with energy, it would just the default would be 100. But if you actually specifically added something for energy other than 100, it would update that. So you can
It'll
change your
override it.
default value just by adding a fourth value,
Yeah,
like an integer.
Yeah, this is just saying, hey, if I don't receive a fourth value, let's just set it to 100. If I
Right.
do receive a fourth value, let's set it to whatever I received. Yep.
Right.
Cool. Now, that is great, right? We've seen that Marley, we've created Marley, and we could do the same with Charlie. Now, there's sometimes we say, okay, not only can our pets do stuff, or not only can we create a pet, but sometimes they all do things, maybe eat or drink. And so maybe we create a eat method. So these are things my pet can do. So I'm going to say eat. Now, when I am dealing with a class, specifically when I'm saying, hey, I want Marley to eat food so she can get her energy up, right? This is what we call an instance method. What an instance method means is it's referring to a specific instance. It's a function, it's a method that affects or is impacts, affects, or is concerned about a specific instance. In this case, I want that specific instance is energy, whichever dog eats. I want their energy to go up by 5. Now, when I'm dealing with instance methods, we always pass in the word self. Always pass that in. Technically, and I'm not talking about this. Technically, if I wanted to make this unicorn, I could. That is not convention. You should not do that. always make an instance method self. And so in the same way that it operates up here, self.energy is saying the specific instance that called this method, invoked this method, that's the one whose energy is going to go up, and then it returns self.energy. So if I were to say something like this, I want to check Marley's energy. I want to check her energy. I'm going to make her eat, and I want to check her energy again. So we come here and we see that it was 50. We see that she ate, and then now it went up to 55. I can also say something like print self.name is eating. 50, Marley's eating, which tells me, hey, we know which specific instance called this. And then her energy is now up. I can say the same thing with Charlie. And because I use self, we could see that allows me just to say, hey, whichever instance of my pet class is calling. So this instance called eat, we make his energy up to 105 because we didn't pass in an energy here. So it defaulted to this 100. I'm going to pause there. Any questions?
I do well. So initially you just wrote the self.energy plus equals 5, and then you put return self.energy, right? And it printed out the 55. But then you wrote the print parentheses, the function equals self.name, that portion 35. Right?
Remember, that's not
This-
function. That's an F
Yeah.
string. That's
F
string
string,
interpolation.
sorry.
Yeah, no, you're
So-
fine. I just wanted to make sure that you didn't think that was a function.
So the F string, being that you put that, you didn't have to write the print Charlie.energy or
I did. So yeah, let's walk through this, right?
okay.
Let's pretend Marley doesn't exist. It gets the line. So what'll happen is Python will read this and it'll say like, okay, cool. I have this class. I know how to set it up. Good. I'll keep that in my pocket for later. And then I say, hey, remember that class, that blueprint? Let's go ahead and fire up the engines. Let's go ahead and make a new pet. So, and the pet's value is going to be Charlie, dog, and 5. And so it goes, okay, great. Let me run my initializer. Use this self to say, hey, the name of this instance that we call Charlie here, this, again, this could be unicorn, doesn't matter. We're saying that instance's name is Charlie. That instance's type is dog, and that instance's age is 5. Then it says, hey, I didn't get another value. I didn't get a 4th one. So that instance's energy is just by default, this 100. So it says, okay, great. I have that. So then it gets down. So it creates that. Our object is now created. Our instance is now created. Then we print Charlie energy. So we're saying, hey, go to that specific instance of Charlie, and I want you to print its energy levels. So it goes into this specific instance and says, okay, energy level is 100. Then it gets down to line 47, and we say, hey, I want Charlie to eat. So it goes up to this method here, this instance method. And it says, okay, for Charlie, because I have self, I only care about Charlie, right? I'm not feeding all animals. I'm only caring about Charlie. Is I'm saying, okay, great. Self.energy, so Charlie's energy, I want to add 5 to that. Remember, this is the same as saying self.energy equals self.energy plus 5. It's just a shorter way of saying that. But these are saying the same exact thing, right? I'm just saying, hey, whatever that energy was, let's add 5 to it. And that's my
Yeah.
new energy.
I'm tracking
Then-
that. I'm tracking.
Yeah, then I'm saying, hey, print because I have the whole instance object, I have access to all of the attributes. I have access to name, type, age, and energy, right? I've already changed energy. But I just want to prove, okay, this instance within this is happening. So I'm saying self.name. So Charlie is eating. Then I come down here and I say, okay, now that Charlie is eaten, I want to print the energy again. So it goes, and because it's keeping track of my instance, then it says, okay, great. Its energy is 100 plus the 5, so its energy is 105.
Okay, got it.
Does that make
got
a
it.
little bit more sense?
Yeah, I for some weird reason, like I missed something, so that's why I was like, hold up, how did you get that?
Yeah.
Okay.
Yeah, no problem. So again, remember, instance methods are things that have to deal with the instance itself. Instance method, right? Where I care specifically about that specific instance or a specific instance, or it is a functionality of my class that involves a specific instance in itself. Now there's something else called a class method.
So that's
Anytime-
why, so
Go
yeah,
ahead.
really quick. What defines one of the things that defines an instance method is putting self in the parentheses. Is that what it is, basically?
Remember, this can be anything we want it to be. We want to keep it as self. And what really defines an instance method is, are we affecting a particular instance of our class? Am I feeding a specific pet? Well, I am, right? So I know that that's going to be an instance method.
Mm-hmm.
If it, is a specific pet sleeping? Yeah. Okay, so that's an instance method, and we're going to put in self. Now, if I'm not dealing with a specific instance in itself, maybe I've got some sort of value here. It's like called all pets. Goes this. But I want to have access to my class itself. I could use what we call a class method. So maybe I wanted to get all of my pets. I just wanted a list of all of them. So it's not necessarily dealing with a specific instance. I just want all of my pets. Well, that's
So an
where we
instance-
create. Give me 1 second.
Yeah.
That's
Okay.
where we create a class method. Now, for us to tell Python this is a class method, we use what we call a decorator. So we say at class method. So Python goes, okay, this next method is a class method. Then we create our method in the same way, but instead of using self, we use CLS. Again, this could be a unicorn or cupcake. It doesn't matter, but we want to keep it as CLS because that's convention within Python. We say CLS. And this is just referring to the specific class and any attributes. So this is called a class attribute. Any attributes the class has. So if I want access to all pets, I can use the CLS, and then it gives me access to that specific attribute. And so this is not dealing with a specific instance, right? I'm not dealing with a specific instance's name or type or age or energy or anything like that. I'm just saying, hey, it's still associated to the class, right? And I want to access a class attribute like all pets here. Therefore, I can use the class method, which allows me saying, hey, it's part of this. We use CLS. And what this is doing is this is adding a pet. I can actually pass in a pet when I run this. And then like say, I would say pet dot add pets, Charlie. So then what this will do is it will And let me print this. Just gives me an object or a list, sorry, which is exactly what I have, of my objects. So if I have Marley, let's go ahead and create Marley, and I want to do the same thing with Marley, just so you can see that there's two objects in there. You see how when we just had Charlie, it just returns a list with one object. But then when we run it with Marley and we run add pets, it gives me a list of both objects, right? Charlie and Marley. Because that's what it's returning. And it's our all pets attribute. So something to keep in mind is when you're dealing with instance method or class method, instance method is absolutely the most popular, right? Most of the time we're dealing with a specific instance. Eat, sleep, whatever. If I'm still dealing with my class, or if I have some class attributes that I want to be able to access, right? Then that's where a class method comes in. I'm not dealing with a specific instance, though here I'm passing in an instance, but just know that I wouldn't have to, you don't have to pass in an instance here. You could just have it with CLS where you're just doing something. Like if I had, let's see, class method, get all pets, just like this. Right? This adds the pets. And this just goes and returns the all pets list. Again, class methods have a decorator and they take in CLS versus self. And then we CLS all pets. And that's what we're getting. We're returning, we're saying, hey, go into this class and there's an attribute called all pets and let's return that. Does that make sense?
You mean there's a method called all pets? It's
Nope,
right
there's
up- right-
there's an attribute here.
Oh, right, an attribute. Okay.
Mhm. Yeah,
there's
so just
also
a
a method.
variable, a variable that belongs to the class is what an attribute would be.
So
Class
so the
attributes.
right, so the attributes are defined between the actual class and the keyword in the class name and the
Yep.
constructor method.
Mhm.
So there's an instance or an attribute called all pets and
Yep.
or yes, and a method called all pets.
There's not a there's add pets and get all pets.
Oh, okay.
Yeah, so you want to make sure that those are different because when I say dot all pets,
Right.
if I had a method called all pets, then it's not going to know which one. So you want to make sure that those are different. Great catch.
Right. Okay.
Cool. And then
Quick
the
question.
last one is what we call a static method. Now, this is the least used method. We might do it occasionally. It's more like a helper method. But this is, I don't need to deal with a specific instance, and I don't even need to deal with a specific, like within the class. So nothing, I don't need any of the class attributes. I'm not doing anything with all the animals. I'm just doing something. So in this case, I am making a sound. And this is printing wolf, wolf. I don't have to, with a static method, I don't have to pass in self or CLS. Yeah, I don't have to pass in either because I'm not dealing with a specific instance and I'm not dealing with any class attributes or anything within the class, right? Now, you might ask yourself, well, why not just make, like, that doesn't make sense, right? Couldn't you just say def make sound out here and it do the same thing? Yes, really. And that's why they're not really used. That's why they're very little used. Let's see what ChatGPT comes up with a different static. Let's see what another one would be. Yeah, get energy. Oh no, that does not make sense. You can't do that. Because you're not taking it in self, so you can't do that. So ChatGPT is wrong there. But yes, a static method is just a method that doesn't have to do with any sort of specific instance, and it doesn't deal with anything within my class. So if we're kind of going back down, instance methods are methods that affect or have to deal with a specific instance in itself. It affects its food, its name, we want to get some information from it, whatever. Class method is, hey, I don't need a specific instance, but I need something within this class, right? Or I want to do something within this class. Let's see if there's another class method it'll give us. Oops. Yeah. This is a way, an easy one where I could pass in this is like a little query. And this is a really common use case for a class method where I could say, hey, I want to give a name and I only want you to return the pet whose name matches what I have to say or whatever I pass in. You could do the same thing with type. So if, you know, if pet.type equal dog, then, or passed in whatever type, then it'll just return all the dogs or all the cats or all the lizards. So I'm not dealing with a specific instance. I am dealing with it as a whole, right? I'm dealing with my all pets. I need access to that attribute, all pets. Therefore, I make a class method with my decorator and I use CLS versus self. Now, please notice also, I don't think I stated it, but static also has a decorator of static method. But again, this doesn't deal with a specific instance and it doesn't deal with anything within the class. It's just a helper function, a helper method. This is just making a sound. Whether this was in this class or not, and that's why static methods aren't super used. Okay, I'm going to pause there. Any questions on this? I mean, that's really all I have tonight. So are there any questions?
I'm not 100% like sure understand the class method, to be honest. Like I'm looking at it and I'm just trying to see, like I'm just trying to figure out how to connect it for me to understand it. But I just can't seem to connect it. Like I got the constructor, I got the instance, but the class, I'm just not. I know that
If
you
I-
have to put it like that, like it has to be equals to the brackets, but I don't understand like.
Well, this has nothing to do with the class method. This is what we call a class attribute. Right?
No,
So it's
I
something
understand that, but what I'm saying
that-
is like, I know that when it's gonna be used, that it has to be written that kind of way. But I don't understand, like, I just don't understand the class method, like the way, like the examples you showed. I don't know, I'm not connecting
Sure.
them.
Sure. It's think about it this way. Let's say that you had to get a secret password, right? In order to get into a building or to get access to some information. Well, if I'm trying to use a static method to get access to, I want to get this elusive list of all pets, right? All pets is not a specific instance, right? Charlie is a specific instance. Marley is a specific instance. So I can't use an instance method there. I want all my pets. I want access to this attribute, all pets. Static methods have nothing to do with the class itself. It's just kind of like, again, a helper. So I can't grab all pets there. So if it's not within if it's not affecting or dealing with a specific instance, and I still need access to something within my class, that is where a class method comes in. So let's just take this one, for example. It's kind of the simplest method here. I'm saying, hey, Python, be prepared. I need access to an attribute within my pet class. That's the only one here, but let's say I had 5 of them. I need access to that. By me saying class method, it's saying, hey, I'm going to need access to that, to everything within this class, like the attributes. Then I say CLS. Again, this could be unicorn, it could be cupcake. It just represents the specific class that is calling this all pets. So when I come down here and I say pet, that's my pet class. Let's say I had multiple classes on here. This CLS allows me to identify in the same way that I needed to know whose name, right? What instance's name equals this? What instance's name equal Marley and Charlie and dog and 8 and 5? Right? In the same way that self allows me to say this specific instance, I want to set its name equal to Marley. What CLS does is, let's say I had a couple different classes. It's saying this specific instance or this specific class, which represents pet. I want to, I guess because this specific class has something called all pets, and I want that. So it's going to go into my pet dot all pets. And so it's going to go into my class. Again, it has nothing to do with a specific instance, but it's going to go into my class and retrieve this attribute here and give it back to me. So it has to do with my class, right? This cannot exist outside of my class. A static method can, right? I could just say a make sound woof and then call that function whenever I want, and then it happens, right? This cannot live outside of my class, but it's not so granular that it affects a specific instance. So sort of in this weird middle area, that's where a class method comes in. I still need access to attributes, not a specific instance, but it is within my specific class of class pet. That help clear anything up?
A little bit, but I'm not sure.
So yeah, so in other words, I think maybe, could you scroll up just a little bit, Will?
Yeah, of course.
Yeah, so it's kind of like the instance methods. Think of the constructor as kind of like a realm almost, and the instance methods kind of are within that realm of the constructor function. You could think of it like that, right?
Mm-hmm. Yeah.
Whereas the all pets, the class attribute that's kind of outside the constructor, that's kind of like a new realm.
Mm-hmm.
And the class methods kind of pertain to that new realm almost.
Yeah. It's sort of outside of this instance
Right.
specific area. Yeah, that's a way to think about it for sure.
And then the static methods, they're just not within either of those things. They just are kind of
Exist.
like, yeah.
Yeah. Mm-hmm. I don't know that we'll use static methods very much, if at all, throughout this course. Class methods we will.
But
And so maybe
so
Estrella, it's just something as we continue through this. Good news is we have a couple of weeks until we start jumping into Flask again. So you'd have a couple of weeks to kind of dive down if this isn't making a ton of sense.
Okay.
We can rewatch still.
Yeah, and
Yeah, definitely.
yeah, for
I'm
sure.
there too, so
And I can keep talking about this. I mean, if in office hours you guys have questions, I'm here to help try to explain.
Yeah, definitely. Yeah, because I got the instance. I felt comfortable with the instance. Just the class method, I'm just not 100% confident with it. I'm not grasping it 100%.
Mhm.
Like I said, I know that I got that it's an attribute. I got that it has to be like whatever it is we're trying to find out equals the bracket. But I'm just, I don't know why I don't know, maybe it's because I'm tired, but I'm
Yeah.
not getting it right now at the moment.
Sure, and that's
question
okay.
with
Yeah, go ahead, Jeffrey.
oh earlier on you said, attributes and methods are the same, right? Or,
No,
Ma-
sorry, methods and functions are the same.
oh, methods and functions. Oh,
Yeah, it's a all of these are functions. If it's just associated to a class, we refer to it as a method. But they're the same, they're still functions, just a function associated with class is now called a method. Same though. This is still a function.
oh, okay.
That's all I was saying. Okay. Anything else? So I know you're not quite comprehending it. We'll keep at this, I promise. But anything else outside of that?
No, I understand everything else. Like, I'm kind of going through my notes, and because I wrote notes with the course modules too, and I had put for methods, it's function, it's like what they do, what we want them to do.
Mhm.
And then like I put attributes or kind of like variables or what they have.
Mhm.
So that's why I understand with the attribute. I guess writing it out
Yeah,
to get the information is what I'm not 100% on.
sure. Well, I will say with practice, it will also very much so help.
Okay.
So we'll
No,
get
that
plenty of
works.
practice. I know it's not fun and sometimes very hard. But we will get plenty of practice in the coming weeks.
Okay. Understood.
Cool. Anything else, friends?
No, this was very well needed for all of us, I believe. I think this was
Yeah.
really good. Will, thanks.
Yeah, of course. Happy to help. And if there's ever anything just like this, like you guys are struggling with that maybe just isn't comprehended, algorithms are great. We're gonna have an entire thing of projects and algorithms. So more so I'm like, hey, if you guys need help understanding this, I'll make that a focus. So. Okay, well, I will stop the recording there.